Hello, have you ever wondered how you can derive the quadratic formula? That's exactly what you are going to do in this video. And we are going to use completing the square method of solving quadratic equations. So let's start. A quadratic equation is generally of the form ax squared plus bx plus c equals 0, right? To complete the square, we need to ensure that this coefficient of x squared is 1. So to do that, we are going to divide through by a. So divide by a, divide by a, divide by a, divide by a. What does that give us? So by a, 1 by a will be left with x squared there. So the first term is x squared, then plus, this is the same as writing b out of ax and then plus c out of a, and this is equals to 0 because 0 divided by anything is 0. Okay, now we are ready to complete the square. And how do you complete the square? To complete the square, you usually take this coefficient of x, you divide it by 2, you square the result, and then whatever you get, you add and subtract it from this left side of the equation. Okay, that's a lot. Let's start small. So first of all, we take this coefficient, which is b out of a, right? Then we divide it by 2. Dividing it by 2 is the same as multiplying by half. Okay, then we square the result, so we square this. So first of all, what does this give us? This is the same as doing b out of 2a squared. Let's leave it in this form for now. So this is what we are supposed to add and subtract from the left side of our equation. So the left side now becomes x squared, then plus b out of ax. Now, before the c out of a term, let's add and subtract this term. So this is the same as doing plus b out of 2a squared. So we have added it, time to subtract, then minus b out of 2a squared. And then let's now continue. We had the c out of a term, so plus c out of a, and all this is equals to 0. So you see that we have added and subtracted the same term. So there is really no difference in our equation. But what has changed is that these first three terms are now like a square. So all these collapse to x plus this term right here, b out of 2a, all of that squared. And let's in fact confirm that if we expand this expression, it should give us the first three terms. So doing x plus b doing x plus b out of 2a squared is the same as x plus b out of 2a multiplied by itself. So x plus b out of 2a. So this is the same as x times x, that's going to give us x squared. Then x times b out of 2a, that is going to give us b out of 2ax. And then b out of 2a times x, that is going again to give us b out of 2ax. And then b out of 2a times b out of 2a, that is the same as b out of 2a and then squared, right? So what does this give us? So this is x squared and then plus b out of 2ax plus b out of 2ax. So you see we are adding the same term twice. So that is just like taking 2 times one of the terms. So b out of 2ax and then plus b out of 2a squared. So by 2 here we get 1, by 2 here we remain with a. So this is equals to x squared and then plus 1 times b, that is just b over a. Then we have the x and then plus b out of 2a and squared. So let's compare. This expansion of x plus b out of 2a squared now gives us the same thing as the first three terms. So indeed, the first three terms now collapse to x plus b out of 2a squared. That is why this method is called completing the square. So let's continue with our proof. So let's write. The equation now becomes x plus b out of 2a squared. Then now the next term is minus b out of 2a squared. So minus b out of 2a squared. The next term is plus ca is equals to 0. So plus c out of a. So plus c out of a is equals to 0. So let's expand this. B out of 2a squared, that's the same as you just square the numerator and then square the denominator. So squaring the numerator, that is going to give us b squared over the denominator is 2a. So 2a and all of that squared is the same as we first square 2 and then we square a and multiply the result. So 2 squared, that is going to give us 4, and then we have a squared because that is the square of a. The sign is minus, and then at the start, of course, we have x plus b out of 2a, all of this squared, and to the right we have c out of a is equals to 0. Okay, now let's deal with these two terms. The LCM of 4a squared and a, that is going to be 4a squared, right? So 4a squared divided by 4a squared, that is 1. Then 1 times negative b, times negative b squared, that's going to be negative b squared, right? Then 4a squared divided by a, that is going to give us 4a, and then times c, that is going to give us plus 4ac. So to the left, now since we took care of the negative here, the sign here is plus, right? And we have x plus b out of 2a squared, and all of this is equals to 0. Okay, so now let's take this whole term and we are going to take it to the right side. So on the left we'll remain with x plus b out of 2a squared, and this is equals to, now this term, you see it's currently, the sign is currently positive, like the whole of it. So when we take it to the right, the sign will change and become a negative. So this is going to be negative, and then we have the numerator negative b squared plus 4ac, and this is all over 4a squared. Okay, so now I think we are starting to get some resemblance of the quadratic formula, but we are not yet there. So what we do here is, you see, when I give you a negative and then this whole term, this is the same as doing negative 1 times then the same term. So b negative b squared plus 4ac all over 4a squared, right? So basically what we need to do is take the negative 1 and multiply through the terms in the numerator. So negative 1 times negative b squared, that is going to be b squared, and then negative 1 times positive 4ac, that is going to give us minus 4ac. This is all over 4a squared. And on the left side of the equation, we have x plus b out of 2a and all of this squared. Okay, so this means that x plus b out of 2a squared is equals to b squared minus 4ac over 4a squared. Remember, we are just solving for the value of x. So the next logical step, since we have this square right here, is to get rid of it. To get rid of it, we need to take the square root of both sides. So we find the square root of this side, and then we find the square root of this other side. So the square root of a square is usually whatever we are squaring. So in this, on the left side, we are going to have x plus b over 2a, and this is equals to, now the square root of any number can either be positive or negative. So we start with that. So that is going to be positive or negative. And then remember again, when I tell you to find the square root of, like we have a numerator of a denominator, this is the same as we first find the square root of the numerator. So in this case, b squared minus 4ac over the square root of the denominator, in this case 4a squared, right? So now we are going to have, in the numerator, we still have the square root of b squared minus 4ac. But what about the denominator? What is the square root of 4a squared? So finding the square root of 4a squared is the same as we first find the square root of 4 and then we find the square root of a squared. So what is the square root of 4? The square root of 4 is 2. The square root of a squared, that's going to be a. Okay, so that's the right side of the equation. Now, to find the value of x, all we need to do is we need to take this term, the term b out of 2a, to the right side. So on the left, we remain with x is equals to, when this b out of 2a comes to the right side, it becomes negative. So this is negative b out of 2a, then plus or minus the square root of b squared minus 4ac all over 2a. Okay, now at this point, notice that this denominator 2a is the same as this other one 2a. So long as the denominators are the same, you usually just you write that denominator there and then you do whatever operation is required on the numerator. So this is going to be negative b plus or minus, and then we write the square root of b squared minus 4ac. And this is the value of x. Does this look familiar? Yes, it does. This is the quadratic formula. And that is the end of the proof. Thanks for watching. I hope you enjoyed this.